Now let us have DC response of RL circuit. As in our second unit, we have transient response analysis where there are two categories that we know. It is a natural response and forced response, and source free response and source driven response. Now we will analyze this source driven response so that same analysis will be there for source free. Only thing is that whatever this V we are assuming here, that is to be considered as zero. Now this is a simple circuit where we are analyzing, because in this unit we are going to analyze three forms for RL, RC and RLC with source driven and source free. So source driven we will be discussing. Same thing is applicable for source free. Only thing is that the input which we are applying, that is to be considered zero. Now simple switch is considered here. It is a circuit consisting of resistance and inductance. The inductor in the circuit is initially uncharged and is in series with the resistor. When the switch S is closed, we can find a complete solution for the current. Application of Kirchhoff's voltage law to the circuit is simple thing. We are going to write KVL. So this will be V is equal to drop across this R into drop across L, and as we know that as per initial condition, drop across L will be L into di by dt. Now let us have first derivative of this equation. So it will be, if we write down, then we can directly, first of all, let us simplify it a little bit so that we will make it a little simpler. So divide by this L, di by dt term, first of all I am writing, then R divided by this L into I, and that is equal to V divided by L. So just rearrange the equation by dividing it L. I want to make it in the standard form of non-homogeneous linear differential equation of first order. So that's why this is becoming dx by dt plus px is equal to say k. So the above equation is I is the solution to be found and V is the applied constant voltage. We are going to solve this equation for I. Only when the switch is closed, the voltage is applied. The above equation is a linear differential equation of first order, and we want to compare it with non-homogeneous differential equation. Now standard format is dx by dt plus px is equal to k. So we are going to compare with this, and its solution of this non-homogeneous differential equation, its solution is standard format x is equal to e raised to minus pt integration k into e raised to plus pt dt plus c into e raised to minus pt, where c is an arbitrary constant, and in a similar way we can write the current equation. So now here instead of x, now we have here di by, so I, our p is nothing but r by l and k is nothing but v by l. So we will substitute the values of respectively p and k. So I is equal to c into e raised to minus r by l dt. This term I have written first, plus e raised to minus, instead of p we are writing r by lt, integration, this k is v by l, e raised to plus r by l t. So we have written this full equation. Now I is equal to c into e raised to minus r by lt plus v by r. So if we simplify and we want to know the value of c, because in the initial condition when t is equal to 0, I is equal to 0. So substituting this condition, 0 is equal to c plus v by r. Therefore c is equal to minus v by r. And now we will substitute in this above equation where we have written the terms. This is 0 to t, and we are writing I is equal to v by r minus v by r into e raised to minus r by lt. Therefore I is equal to v by r common into bracket 1 minus e raised to minus r by lt. Just I have missed here minus sign. Just remember this is a minus sign. These are the two parts where this second term that corresponds to the transient part, and this first term corresponds to steady state part. Now if we draw the characteristics, then it will somewhat look like this, where the transition period is defined as the time taken for the current to reach its final or steady state value from its initial value. The transient part of the solution is the quantity L by R is important here, and this is nothing but acting as a time constant, and v by r e raised to minus r by lt is the time at which exponent of e is going to become unity when e is the base of the natural algorithm. The term L by r is called time constant denoted by tau, and it is L by r. So you can have expression as a transient part of the solution is I is equal to v by r e raised to minus r by lt. Minus sign again I have missed. Now at tau, where in general the time constant for various values of t you can find out, and you may obtain some such values. In general, it is observed that 5Tc is a transient part reaches more than 99% of its final value. So therefore, this is very much popular time constant figure. And voltage across inductor, if you want to know, then VL is equal to L di by dt. So L into d dt of this I equation you can substitute and little bit rearrange and substitute, and you will get VL is equal to V into e raised to minus R by Lt. I have done here substitution. Just see d dt of V by R minus V by R d dt of e raised to minus R by Lt, and this first term is 0 minus initial conditions we are going to put t is equal to 0, and if we simplify it, then we will get the constant, and rest of the time we will get the actual equation, that is VL. If we look at the characteristics, then the responses, this is VL is going to come down and VR will gradually increase. So this is a power characteristics, and power in that resistor will be PR is equal to VR into I. So VR into this equation for I we have written, and the power in the inductor will be again PL is equal to VL into I. So accordingly, same fashion we have written the equations. So this way you can consider the DC response of RL circuit. Basic equation you have to remember is equation of the current, and that equation is nothing but this particular I is equal to V by R into bracket 1 minus e raised to, here you consider minus R by Lt. I have missed this minus sign, but you remember that this term, otherwise you can remember V by R minus V by R e raised to minus R by Lt.